Okay, thank you. I have two things. First one goes to Joey. Can the cluster support, can it be retrofitted onto like remotes? Like, can I convert a current remote where I have, for example, 1 terabyte of storage and I run into that limit, and now can I add another 3 terabytes on other machines and then just continue, basically?
Yes.
That's exactly the kind of answer I expected. Awesome, thank you so much. And the second one goes to Matthias. You have tests, what? Really? That's great. No, that was not, I just wanted to note something. You said that inputs to papers and research should be open and shared and made available, and I absolutely am absolutely with you on that. I just want to remind everyone that we're in a bubble here, and that's just not the reality we currently live in, and it will be a really hard piece of work to get that going. I have insight via my wife to chemistry students, actually, PhDs, and the reality there is that they have proprietary data that's sent around in teams. So that's the reality today, and getting everyone to have open data shared for papers is going to be a really hard piece of work. That's just a note. Thank you.
So adding to that, I should clarify that sort of my vision that I presented is an idealistic view, and the solution to it lies somewhere on a spectrum, and you can get closer to it step by step. So I think we should make an effort to bring that outward as well, to like do small steps towards this goal. It cannot be just come by itself in its entirety. Yeah.
Thank you. Yeah, very interesting talks. I have a question to Michał. So we know the pain of storage limits, and inode limits. So that's why we are using data.NX and Uncurl Special Remote. So we have 2 files that we can clone from, and then all the data is, when you do data.get, it's downloaded from an URL that we configured. Now the question is, can we combine this with this data.make? Because it would be good if we could just recompute the outputs on data.get, and the inputs are just gotten from the URL that we specified.
Yes, so the key step here would be provisioning. So when you're getting that file with data.remake, you have this work tree provisioned, and then in the work tree, the get command runs just like as it would elsewhere. So if it needs to fetch some files that you specify in inputs, and it uses data.get, which uses git annex get, which uses whatever method there is. So the answer would be yes. Even stacked compute remotes should work, but then things, I think, can become tricky and ineffective very quickly. But the short answer sounds like should be possible.
That's great, thank you.
And that's an interesting difference between git annex compute special remote and what you were talking about, because in the compute special remote, it tracks the dependency tree and reruns all the necessary dependent computations that it needs to get, missing files up the tree to get to what you're actually building.
Okay. That's nice.
So my question is about the 4Geo soft fork. So the GitHub, the 4Geo actions thing is kind of an interesting problem space, because when we talk a lot about compute reproducibility, and those are the things in 4Geo that should trigger some actual computations. So I think there might be potential for a better integration into the kind of rest of the 4Geo ecosystem, into the Git Annex ecosystem. So did you think about this? Is there any work into this direction? What's your ideas on this?
So for JO Actions is basically, you host a runner and you have this event-based system. If there's a push or if there's a scheduled event happening or some other kind, I think you can also respond to like newly created issues with workflow runs. And what you actually do in that workflow is entirely up to you. So it's like very similar in syntax to GitHub Actions. So you can run arbitrary scripts, arbitrary code, and in that code do whatever you want. You can execute a data-led run. You could execute like a data-led, well, I don't know if it would make much sense to use remake inside of a workflow, but you can do all those kind of things. Well, for JO Actions is based on container technology, so you are already inside like an isolated container there. But I haven't thought of any like deeper integration than that.
Yeah, so my problem with this is kind of you also, so for example, you deploy an output. Basically, maybe it compiles the documentation page, and then this documentation page is mostly pushed to some web server. But you don't store this artifact usually in the Git then, and this is kind of the missing piece for a lot of things that are attached to the software development projects are the artifacts generated by the CI pipelines, but they are not stored in the Git anymore, and this is kind of the missing piece I see there.
Yeah, but nothing is stopping you from pushing to the repository inside of such a workflow. Like I think I've skipped that slide, but with these with error 5 dataset, at the end there's like a data-led recursive push that just pushes all the updates made to the dataset into the dataset itself. So yes, you can store the artifact outside, but you can also store it inside the repo.
First of all, I want to thank Steffen for finally figuring out how I could call myself data herder, right? So that's the new term for me. So instead of describing neuroinformagician or something like that. And first question would go to Matthias and Joey. How could we establish some apprentice program maybe, so we could a little bit dilute of buzz factor here? If we start trusting those efforts, well, we trusted already for a while, but we cannot guard you all the time. And how could we facilitate, those efforts to keep going on healthily? Any ideas?
I mean, this is a really important question that I'm probably the wrong person to answer, but I think that and this is also something I was wondering about watching your presentation. What happens if maintenance for some reason stops? But you seem to have built a foundation that would let it be picked back up if you weren't able to work on it for whatever reason. And I don't know how we solve these problems. The best I can think of is have a well-documented system, and assuming, say, that someone doesn't want to work on Haskell and wants to continue Git Annex, would they be able to replicate it in Rust, for example? I think that's something we should make sure is possible, which it is, but it should be, we should build, we should think toward the future in that direction too. It's important to have a specification of some kind. We don't have a specification for Git Annex as is, and I think there would be kind of, if we were making a specification for Git Annex, we may want to change some things, which of course is always a problem with specifications. But yeah, I think you need to look in that way.
Yeah, so for JO and Exarcher, I think the issue is much smaller than with Git Annex. So I've shown the patch set is relatively small, especially when you account for how much of that is tests. I have already taken over from someone else, and I think it is in a state in which if I were to disappear tomorrow, someone else who wants to could and with some Git annex and Go knowledge could pick it up if they are so inclined. And also, like I mentioned it on the future Outlook slide, there is a path to upstream this into Fogeo properly. And at that point, if it were there, then a lot more hands would be able to take over maintenance. I don't think Fogeo and Exargo as a software fork would go away entirely. I think it's still very useful as like an experimental test bed, even if most Git annex related features were upstreamed. But yeah, I think if we get to that point, then that issue is diffused largely.
I think I'm really interested in what might be needed to upstream it, but I also remember GitLab for a while supported Git annex, at least, it had very simple support for it, and then it got removed. And I think it just happened because they were simplifying their product and not enough people were actually using it that they knew of. And so that's always a risk too. You can't come up with a solution to a problem like that, but I am really curious about it getting upstreamed eventually. It seems like a really nice direction to go in if possible.
As mentioned, there have been like some initial discussions, like an opened issue and some back and forth, with the idea of making it like at first an experimental option in Fogeo. And I think that could be a direction to go, especially as long as not everything of all the features of Git annex are properly integrated. I forgot what to say.
I could put some words into your mind then maybe. What I was thinking while you were presenting it, and that's why I mentioned Apprentice, maybe we should prepare and propose some projects for something like Google Summer of Code, or maybe even apply it to CZI, because this is critical infrastructure now, right? And finding support, and then people who would do their maybe toy projects on top of it, maybe not so toy, it will familiarize them with those projects more and contribute more. So maybe we should expose them as the projects where community could actually come in, and we present them explicitly like that. So maybe we should look into that.
I remembered one point. So what's a roadblock in upstreaming is actually just time. So I'm really maintaining this project on the side next to like a bunch of other responsibilities and projects to work on. So I just haven't had time to put effort into cleaning the patches up properly to get them into Fogeo. So that's
Maybe a different kind of question. There's a bunch of people using Boutique for specifying input/outputs of program or pipelines. Is there any interest or sort of a utility in attaching that to data run or Git annex compute or like this?
So maybe I'll start. So with Datalat remake, we have spent a good while thinking of what would be the best specification of inputs and outputs. That's why the mention of common workflow language, for example. So the idea then was many things already either take that or write that. So maybe we could use that. And there was also, of course, the Datalat run record, so the thing that Datalat run writes into the commit message. And in the end, we decided to go for the simplest solution, so take the barest minimum of what we would need, so just what the parameters, so you can have some flexibility, and just the command as it would go into a sub-process. in the future, I can imagine this coming back.
So when I was designing GetNX Compute, I actually started exactly where you ended up. It was almost identical. And what put me off of it was you have kind of the duplication of parameters when the end user is using it, where they have to say, here's the file and it's the output, it's the input. And I didn't like that, and so I just kind of thought about the Unix philosophy, make it as simple as you possibly can and as flexible as you possibly can, which is why I went with more of a command line approach, which of course makes it more complicated in another place. But I do think that given GetNX Compute, you can make a GetNX Compute program that uses a specification if you want to. So come up with any specification that you like, or for example, yours, we could have a compute program that uses it.
Maybe that's a good time for that kind of question that I'm going to ask. In your talk, you basically have shown that now behind a remote, there's a whole world. And the only reason why we need to even have to think about something like data-led remake is that another dimension, which is the repository, doesn't have that same world to it, right? So if the compute remote could be asked, or the compute remote facility could be asked to produce a key from a different repository,
Yeah,
it's
so
magic from there on.
right, you're talking about submodules.
Well, whatever, Lloyd, I'd like to think about it as you will probably come up with a great solution, but the idea of that modularization, right? That some things shouldn't be all together smushed into one repository. That's a valid and completely independent thing, right? But if GitNX could do some type of bridging that it does for the remotes, also across repositories, it would open up a huge opportunity space.
That's interesting. We'd have to talk about it more, I think, or think about it more. It's an interesting thought. About submodules, GetNX Compute doesn't support them only because I punted on it. I just said, maybe we should support this, but it's too hard to bother with in the first pass. And of course, DataLad cares about submodules. GetNX has tried to avoid doing anything with them and let higher level tooling like DataLad deal with it.
We had a few questions here at the back. Who had their hands up? No one. Oh, you. Thanks.
I had a question for about the tape special remote and just about transferring files, transferring objects in general. Just from my experience, I did run into a bunch of corner cases when I've done experimentation with trying to optimize transfers. Like for example, if I send to a host that doesn't, with a less powerful CPU or one that's not as optimized for SHA-256, that can be a bottleneck. And also if I'm sending to a spinning disk, I don't necessarily want to use parallel because that can increase fragmentation. So just really quick, one little trick I did is I would just get a list of keys, rsync them to the git annex mistemp directory, and then asynchronously let it use reinject known or something like that. And I was just wondering if either of you guys could talk, or anyone, your thoughts on if you've looked into that more, or strategies for dealing with special needs of specific devices, stuff like that. Like, you know, computing the hash on the fly instead of, like how it does it now, instead of, you know, waiting until they're transferred, stuff like that.
think I'm going to comment quickly on the performance and the processing involved with writing to tape. It's fairly simple, as we can utilize the hardware encryption of the tape drives. And I did some tests with the GPG encryption instead, and if you push a lot of data, that's going to significantly slow you down. And by using the hardware encryption, I can counteract this. Other than that, I think on fetching objects from a special remote, GitAnnex is always recomputing the hash to verify that what you are injecting back into your repo is actually correct. And I'm not sure we can save that. I think the special remote protocol has facilities nowadays for streaming objects that's used in combination with the proxies, I believe. It's just like ordered attribute. So maybe we can also compute hashes while streaming data from a tape drive, but I think Joey can answer that.
Gosh, I would have to refresh my memory, actually. I don't remember. But I do know that GitAnnex tries to do checksumming on the fly while a transfer is happening now, which it didn't used to do. But I think generally, GitAnnex doesn't know about what is a good order to do things or how much parallelization is appropriate on any given device. And it's something that needs to be configured or dealt with in some way. And there's probably a lot of room for improvement here. And I really wonder about this tape remote. Maybe this is going to push us towards something general that will be useful beyond it, because you do have, of course, your problem of retrieval and ordering. And I'm really interested in collaborating and trying to solve that problem. It's the big obvious problem that you have, but also when, say, using Glacier, GitAnnex also has the same problem. Of course, Glacier has its own weird system of dealing with this. And you end up with kind of a two-pass approach both times, which I think is a good starting point. Maybe we could make a two-pass approach not look like failure in the first pass and just look like, well, that's deferred or something like that. I wonder what you think about that.
Yeah, exactly. I think we might need to extend the external special remote protocol for that, but it might be a fairly small change. Regarding the parallelization and how that affects performance, tape drives are super easy. It's a sequential media, so you cannot parallelize. You have to write one object after the other. So that makes it simple. There is an aspect, and I touched on that, that I want to add support for asynchronous I/O. Right now, the external special remote protocol also requests or stores each object individually, sequentially, and that has issues sometimes because we need to get basically have the tape buffers, the buffers of the hardware device always filled, and that might be a problem.
Here at the back.
Yeah, so one remark, because we were talking about verifying hashes and streaming. I think with SHA you will run into issues there because it doesn't stream verify so well, but there are other hashes like the Blake family of hashes that are now being used. I don't know. I have no clue about implementations of GitAnnex, but if you want to look into streaming verification, at some point you will run into SHA not being stream verifiable. But anyway, that's just a comment on that. Yeah, and what I wanted to remark was this one slide that really felt like a bit of a punch to me, so I cannot resist to comment. It was this slide that had something like forges and centralization on the top, and then something like GitHub showed that it can be good or something. And I know that the whole talk was about for Jeho, and I know that the idea there is federation, and they're actually working in a completely different direction. And I have a lot of respect for people working on for Jeho and for the extensions. Yeah, but I cannot help to comment saying that maybe we should question how good of an idea it is to put all our code as in the open source ecosystem on one forge and have that forge owned by one corporation. You will hear more about that tomorrow in my talk, but as I said, I cannot resist to make this comment.
Does anyone want to respond to that? More questions?
I can only say that I agree with you. Like, especially with all the AI features and what they've introduced into GitHub lately, I'm not sure they are the best place to be anymore as an open source project. That's why Vogel and Xarjo itself is on Codeberg. And I think, especially with Federation, it will be very cool to see if we can get like smaller communities distributed, but still having the huge upside of centralization, which is searchability. I think that's an important point that GitHub has and that we need to replicate somehow.
A quick question connecting to that, because I'm using Forgio and Xarjo also myself on my little NAS here. And I don't have all the objects always present on the Forge. Maybe I missed it, but do you plan to add like basic support for git annex get and drop to the web interface as well? Because so far I haven't seen any way like how I can deal with non-existent data, and it seems like you're using it mostly in the assumption that data is actually stored on the Forge.
So yeah, that's something I haven't fully thought through yet. The basic assumption right now for how we use it is that you store the data on the Forge. So if you want to have it like visualizable by these custom file previews, for example, it has to be there. You can always, again, Forgeo Actions, automate your things. You can run git annex sync in a Forgeo Actions workflow and configure some kind of wanted configuration for the repositories on what file you want where. That can work, but doing it by hand, you would have to use a command line like drop from.
So if your Forgeo repository has a GitAnnex repository on it, you can make that a proxy for the other remote, which you all say your tape or whatever other remote you're interested in. And in that case, GitAnnex would be able to download from Forgeo and go through the proxy to get to it. As far as Forgeo, if it wants to display the file, it would still have to do, you'd have to do something about that. But I do think it's theoretically possible that you could just stream the data right out of the proxy into your HTTP response, basically, and not have to deal with, keeping the file around or something like that.
I just wanted to ask or comment on batching and async. To a degree, async, I believe, if I remember correctly, was introduced pretty much to something like that to provide batching, so backend could decide, oh, this will be the order in which I received already 10 requests. Okay, let me now order them so I could respond in that order. And that's where actually parallelization would be also beneficial, because then it's like could all come, together if you have some backend then which batches multiple requests and again responds in those 10 workers, let's say, which respond then in that order, which backend decided to do it asynchronously. Could that provide a solution?
Well, it works up to a point, but you have a number 10 in there, and with a tape, you want everything. I think that's kind of the essential problem. Things would stall out. GitAnnex would be like, I've got 10 workers. They're all waiting for this operation to complete, and say your tape remote would be waiting for everything it needs so that it can order everything. So I don't know how to square that circle, but you're right. That is kind of, yeah. You're right.
Okay.
I would quickly add to that. I would like to see another version of async support for backends, maybe also because I'm dealing with hardware directly here. I don't have an operating system basically in the middle doing caching. So what happens if I write to a tape and that fails? Like what I do right now is I sync after every object. And that's super expensive. It slows down the tape. So if I have a way to defer the confirmation that the transfer was successful, basically having an asynchronous way of initiating multiple transfers and then saying, oh, now this one is done, would be super useful to solve around that synchronization and hardware limitations. I mean, it happens the same if you have a remote writing to disk. We always assume that once you wrote to disk, it's actually committed. But what happens if you shut down your system, you still have stuff in your page cache? Could be a problem here as well. And if you want to really use direct I/O, write to disk, get it synced, it's not going to be efficient with the current design, I think.
So I think that for that, async is exactly what you need, because you'd be saying, for example, you'd be pushing with DESJ10 or whatever, and as long as your backend, it can do the sync once the queue is empty, and then GetAnix will send the next batch over. So I think it might work.
True,
Yeah.
Okay, thank you. I want to comment on the centralized forge comment from earlier. I think the problem with GitHub, let's just leave out the AI problem, but Git is already decentralized, right? So we can move code away from GitHub without any issues right now. The real problem lies in that it's not about the code. Students today get told everyone can write code, but not everyone can communicate. So it's all about the stuff around the code. And I think the federated approaches are our fastest way and our easiest way away from like the centralized code forges. And but they can only be like the beginning of the whole thing. And I'm still a big fan of the email patch workflow, where everything is in emails and you can just distribute them. And there's a public inbox, for example. You can just clone a public inbox and have all the history of a project, including the documentation, basically, that went into emails, into conversations. And yeah, we'll probably hear more about a solution to that problem tomorrow. Yeah, but that was just my comment.
Well, I'll answer your comment with a comment, which is that I have a to-do item somewhere in GetAnix to have a standard format for emailing patches that contain GetAnix objects around. Never implemented it,